Okay, good day, students. Okay, this day we discuss about the one-to-one function and its inverse. After the discussion, the students are able to present one-to-one function into real-life situations, understand the properties of one-to-one function, and solve the inverse of one-to-one function. Okay, so let function f be a one-to-one function with a domain in a set A and range in the set B. Then the inverse of f, denoted by f to the power of -1, is a function with domain in the set B and domain in the set A, a range in the set A, defined by f inverse of y equals x. F and only f of x equals y for any y in set B, and also y value is never paired with two different x values. Okay, so we have an example. Determine whether the given relation is a function. If it is a function, determine whether if it is one-to-one or not. Okay, number 1. The relation pairing an SSS member to his or her SSS number. The answer is the relation is function and it is a one-to-one function because SSS member is assigned to a unique or one SSS number. Okay, number 2. The relation pairing a real number to its square. And the answer is the relation is a function but it is not one-to-one because two different real numbers may have the same square. Okay, illustration, y equals x squared. Then if we substitute x equals 2 to x squared, the answer is 4. And if we substitute x equals -2 to the x squared, answer is also 4, meaning 4 paired by 2 and -2. Then in the definition states that never the y value paired more than one x value. Okay, number 3. The relation pairing a person to his or her citizenship. And the answer is the relation is not a function, and also meaning if it is not a function, it is not also a one-to-one function. Okay, so properties of an inverse of a one-to-one function. Okay, number 1, if the ordered pair x and y is on graph of f, then the ordered pair y and x is on the graph of f inverse. Example, the relation f or this relation is a function. Okay, then the inverse of this function. So this is the inverse of the function. Okay, number 2, the f composed of f inverse of x is equal to f inverse composed of f of x, and that is equals x. Okay, example, f of x is the original function to x plus 5, and the inverse is f inverse of x equals 1 over 2x minus 5. Then f composed of f inverse of x equals x, and f inverse composed of f of x also equals x. This is the proof. So the f, you write first the function f, then insert the f inverse, that is y, 2 times 1/2 of x minus 5, then plus 5, then cancel 2, then the remaining expression x minus 5 plus 5, that is equals x. Okay, so next we prove this f inverse composed of f of x equals x. This is the proof. 1/2, that is, you write first the f inverse, 1/2 times x minus 5, then insert the f of x, so 1/2, and it becomes 2x plus 5 minus 5. Okay, so it becomes the 1/2 of 2x, and that is equals to x. Okay, number 3, the graph of f inverse is the graph of f reflected about y equals x. Okay, this is the example. Okay, so this graph is the f of x. Okay, this graph is the f of x equals to x plus 1, and this is the graph also of f inverse, that is x minus 2/2, and this is the y equals x. Okay, so the number 4, the horizontal line does not intersect the graph of more than one point. Okay, so this is the horizontal line, so intersect one point. This is also the horizontal line, intersect one point, and that is also the horizontal line, intersect one point. Okay, take note that a one-to-one function satisfy both the vertical and the horizontal line test. Number 2, a function has an inverse f and only f it is one-to-one. Okay, steps in finding the inverse of one-to-one function. Number 1, write the function in the form y equals f of x. Interchange the x and the y variables. Solve for y in terms of x. Example, find the inverse of f of x equals 3x plus 1. Okay, so solution, first solution, y equals 3x plus 1. Write f in the form of y equals f of x, step number 1. And the step number 2, interchange the x and the y variable, that is y, it becomes x equals 3x plus 1. Then step number 3, solve y in terms of x. Okay, x equals 3y plus 1. Then solve for y, x minus 1 equals 3y. Then divide both sides by 3, and it becomes x minus 1/3 equals y, or y equals x minus 1/3, and that is f inverse of x equals x minus 1/3. Then example number 2, find the inverse of f of x equals x minus 2/3x plus 2. Then y equals x minus 2/3x plus 2. The step number 1, write f in the form of y. Step number 2, x equals y minus 2/3y plus 5. Interchange the x and y variables. Equals negative 5x minus 2. Then factor out y. It becomes y equals 3x minus 1 equals negative 5x minus 2. Divide both sides by 3x minus 1, and it becomes y equals negative 5x minus 2 over 3x minus 1, or f inverse of x equals negative 5x minus 2 over 3x minus 1. Thank you.